Hello, so today we're doing some Oxy Propane on the train. I'm going to make a side tank and I'm going to use brazing rod to do it. So as you can see, the train's come along a bit. I've done one side tank which was TIG welded. I've run out of argon gas, hence I'm doing the Oxy Propane. I've painted it all up to stop the rust. I made this out of some, I think it was 2mm steel, some sheet steel. It was purely because brass is really expensive and steel's dead cheap and I get it for free, so I thought I may as well use it. Going to give the steel a quick clean up with a wire brush, although you don't really need it as clean for brazing rod. It seems to sort of flow into a joint regardless of how mucky the steel is. This is why I prefer it over silver solder at the moment. So I haven't got the book on me at the moment, or the plans, so I'm just going to take the measurements from the other side tank I made. That way at least they're both the same and they look sort of symmetrical. So this is all the parts cut out and ready for brazing together. I just put a bit of sort of a prep on them just to make sure that it was clean enough for the braze. And this is the Oxy Propane kit. That's the propane bottle and the oxygen bottle's over there. And that's the torch I use. It's got a mixer on it. You've got one for the propane and one for the oxygen, and it's got the sort of gas welding attachment torch on it. I don't really know what to call it. If anyone wants to put it in the comments what that's called. And this here is the cutting attachment for Oxy Propane. You can reach temperatures of 2,800 degrees with it, as opposed to, I think it's about 3,200 with oxyacetylene. So anyway, that's the regulator for the propane, and that's the flashback arrestor, which stops any flashback reaching the bottle. And of course you've got the same on the oxygen. You've got the regulator and you've got the flashback arrestor. And as you can see, all of the tubes are wound out fully and they're actually over the back in the workshop. And this is the flux I'm using. It's just a unibronze flux. Just dip the brazing rod in it once before you use it, once it's heated. So now we're going to go over how to set the torch. Now what you've got is you've got your mixers. I just crack them open and close them gently, or else they tend to sort of fly open too quick and blow the flame out. So I'm lit it up. Just going to increase the gas, and you'll see the flame escapes the end of the nozzle. That's because I put too much gas on, so I backed it off a touch. And what I'm looking for is for when the soot just seems to thin out. Then I bring in the oxygen gently. See the flame escape the nozzle, so I went back. I very gently bring in the oxygen until I get that nice little cone flame. It's quite a noisy process, Oxy Propane. I don't know why it pops and crackles as much, but I seem to get the hottest flame when it's popping and crackling as it is. But here you can see the little cone-shaped flame. The tip of the cone on the flame is supposedly the hottest part and the most controllable part, but I tend to find if I just come away from it slightly, I tend to get a touch more control over it. So here I'm just mellowing out the flame a touch by messing around with the controls. I tend to just put a little less gas on and then back off the oxygen, and it mellows out a hell of a lot. And you can see I've got a smaller cone. I tend to use this for the brazing. And when you're turning it off, you must always turn off the gas first, then shut off the oxygen. So this is the brazing process. I just thought I'd put a small tack on, because you can tack up a job with Oxy Propane, because you're only heating such a small area. You can tack it and it will hold. This is why I prefer it over a big propane burner, as you don't have to heat the whole workpiece, and you can just go along almost like a TIG welder. The only difference is the material just flows in, and it will flow anywhere there's flux or anywhere where there's heat, really, because it's brazing rod. It's not as fussy about where's fluxed and where's clean. Right, so I did one half, and I'm just going to heat the rod up. This is what I was talking about, and you heat the rod and then you dip it in the flux, and the flux sticks to the rod. This is all you really need. It just cleans everything as it goes along. I'm using a thicker rod here. It's probably too thick for the job, but it means I don't have to feed the rodding in my hand as much. So I just tack the corner, and I'm going to go along and just touch in a little bit of braze every now and then until it flows in nicely. You can see it a lot better when you do have the brazing goggles on. It's a good idea to wear them. And there we go, that's one finished joint there. And this is the finished tank before cleaning up. As you can see, it's gone rather well. It's very square, it's very strong, it's watertight. There's a few spots where there are some gaps in the braze. I can fill them in with some more brazing rod, or I can just leave them and use some filler later or something. After all, it is only a water tank, it's just going to hold water, there's no pressure in here. So you can see it cleaned up quite nicely after sanding all the corners round on the belt sander. Just going to test for water tightness now, so I haven't got much water, but it will test the joint that I thought was particularly bad. As you can see, it's bone dry. There is nothing leaking out of it. I'll rub my hand along the bottom, you can see there's no water, so brazing has worked really well on this. Overall, I'd say jobs are good, I think.